Hello everyone. Today I'm going to uh, talk and present about our project. Our project revolves mainly around this component. It is the sound sensor. It is able to output both digital output and analog output. In this project, we mainly use the analog outputs because in our opinion, the digital output doesn't provide much benefit except setting an alarm when the volume goes to a certain level. So we mainly focus on the analog side because it's more fun that way. Our project do two things. It detects uh, sound waves and display it on the LEDs, and it can use it switch to switch mode to the other mode which is frequency detection mode. It will detect sound frequency that will hit it and will display it in the same LED. All of this is done by splitting the analog output of the sound sensor to wire to both the digital input and analog input of the Arduino board. In the sound wave mode, the LED will light up in both ways. It can fluctuate up and down like a sound wave, which our theory is because it detects the air pressure of the sound when it's bound back, so it go up and down. And in the frequency, it start from here and then go up when the sound pitch is higher. And that's we'll go next to the next part now. For the circuit explanation part, we have the Arduino as our main microcontroller. We have the sound sensor that use the analog output to pin A5 on the Arduino Uno. This part is all for the LEDs array with 230 ohm resistors on all of them, a total of 9 LEDs. This is for splitting the sensor output. For one is for analog output, input for the input from the Arduino perspective, and one is for the digital input. And this is the switch that will switch mode from the analog input and digital input with 10k ohm resistor in the switches in the pull up configuration. The circuit is quite simple, and
Okay, so now we're going to take a look at our code. So the first part, we define all the variable that we're going to use, which is frec, gain, and analog average. This one we'll be using in gain. And the next part is set up pins for LED, sound sensors, switch, and we define the state equal to 1. In the setup, we basically just set up inputs and outputs. Now we're in the main parts, which is the loop. In the first 3 lines is to switch between states, wave and frequency. So we let the state wave equal to 1 and let the state frequency equal to -1. And that's why the states right here, we have to times -1, so that when you click the button, it will just directly change. Okay, so in the stage 1, which is the wave one, we just let gain equal to analog average, and it's read the value directly from the sound sensor, and then we call the function wave. And in the states frequency, we define function on and off, a value on and off. So on is when the graph went up, and off is when the graph went down. And then we added up both of them, we get period. And then we put all of these into the frequency formula, which is 10 power by 6 divided by period. And this line right here is especially for frequency because you don't hear anything above 20,000 hertz. That's why we make sure that it will never go above that, and then we call the function frequency. Okay, and now we're in the wave function. So we define the offset gain here because in the graph the average start at 565. That's why we minus the 565 so that the graph will start at 0. And in the wave mode, the starting LED will be at the middle, which is at the pin 4. That one will always light up. And we use the offset gain here in everything else. So if it's meet the condition here, the LED will turn on depending on how high it is and how low it is. And in the very bottom here, this is to make sure that the LED that doesn't meet the condition will always turn off. So we use the for loop here. And the frequency function here, it's a little different from wave. First of all, it doesn't have to define offset because it will always start from 0 anyway. And the second thing is that in the frequency mode, the starting LED will be on the left side, which is at the pin 0. And the rest is pretty much the same as function wave. If the frag value reaches the condition, the LED will just turn on, and if it doesn't, it will just turn off. And that is our code for the project.
Now for the circuit demo part, I'm gonna demo for you 2 ways. One is from music and one is from ML. Both the wave mode and the frequency mode. So I'm gonna you can see that when the music beat drop or it's getting louder, the LEDs start flickering more in both ways, which correlates to the waveform that the sensor is picking up. And if we push this button, it switch mode to frequency mode, which detect frequency of the sound that comes into contact with the sensor. It's better if I use myself. The wave is so that's the, and if we press again, it comes back to the waveform mode. And that's the demo for our group project.